Hi all, welcome to the YouTube channel of Organomed. So friends, I hope all of you are fit, fine and happy in this pandemic lockdown, doing well in your Today's video is going to be all about Chem Sketch, how we can use Chem Sketch, how we can draw molecule or structure of our interest on Chem Sketch. Alright, and I will suggest you that if you had not watched how to download and install ChemSketch, then please watch it first because then only you will get ChemSketch and you can draw structures or molecules of your interest using ChemSketch. Alright friends, so let's get started. So friends, as you can see, this is the home page of ChemSketch or acdlabs, and there are various icons you can see. Alright, on the left hand side, right hand side, and on the topmost panel. Alright, and I'm going to explain each and every icons, what are their uses and how we can use them. Alright, and alright, so let's first of all start with the icons on the left hand side. Alright, and on the left hand side you can see there the first one is the periodic table of elements. Alright, so this is the icon of periodic table. Alright, as you click on it, the whole periodic table here. Alright, and you can see. Alright, so this is the classic periodic table. If you want to change it to aggregation state, you can just click on here. Alright, so you will get a periodic table on the basis of aggregation state. Here aggregation state, what does it means? That is, all the elements are classified according to their normal states on which they exist, like solid, liquid and gas. Right, so you can see this is these all are the solid. Alright, so these highlighted light blue colors are the liquids, and all these nitrogen, oxygen, fluorine. Alright, and all these are the gases, like they exist in the gaseous state. Alright, and if you want to see in terms of metals or non-metals, just click on here and it will appear like this. Alright, so these are all metals and these are all non-metals. If you want to see them on the basis of their radioactivity, right, so all the highlighted elements here are radioactive elements. Alright, and if you doesn't want any one of this, just click on none, and this is the simple periodic table. Alright, and so I just choose here, I'm just choosing here classic periodic table, as this is of use like if you want to place any particular element of your interest on any molecule or compound, then you can choose this periodic table and you can select any element from here. Alright, so once you select, like as I had selected zinc, so it will show you the mass, its oxidation state and its electronic configuration. Alright, along with its atomic number. So this is going to be like this. Alright, and there's no image available. Alright, so this is the coloration property of the periodic table. If I went on to the mass, right, so let's say once you select any element like scandium. Alright, so at the bottom, like here you can see its isotope 45, isotope 46 and their percentage abundance. Alright, their mass is given. Likewise beryllium. Alright, so its isotopes and their percentage and the mass is given. Let's say hydrogen. Alright, so it's also its percentage abundance and mass is given here. Alright, so this is the mass. And if you went to NMR, let's say I want to see the NMR of hydrogen, so you can see the magnetic moment, the magnetic ratio, frequency and receptivity. All these have been shown here. If you went on to general, alright, so like say I select as boron. Alright, so it will show you its characteristic features, like which color or in which state it exists, like monoclinic yellow or brown amorphous powder. Boron exists in the form of brown amorphous powder. Alright, who discovered the element boron? Alright, so it's so H. Davy from England and L. Lussac and L. J. Thenard from France. They discovered this element boron. All right, and then the name origin. All right, it's burak in Arabic, means borax. All right, along with it, it's atomic radius, electronegativity, ionization potential, electron affinity, density, melting point, boiling point. All these general features are provided here. All right, so this is the basically the periodic table. Like if you want to select any elements, palladium, all right, so you will suggest it, select it, and you can paste it here, so it will appear here. All right, and now if you want to delete it, all right, so this option is of delete. Just choose it, click on it, and it will be deleted. All right. Alright, so now below the periodic table option, you will find various elements like carbon, hydrogen, nitrogen, oxygen, fluorine, sodium, silicon, potassium. These are the frequently used elements we use in any chemical structures. We use most frequently these elements, so it has been placed here. If you want any other element of your choice, you can also drag and paste it here. Alright, so it will be shown here. This one is the text option. If you want to write any text, then you can choose this. And this one is the radical label. Like if you want to label any radical, then you can choose this. Right. All right. So these are the icons or symbols on the left hand side. Moving on to the right hand side panel, here you will find the table of radicals. This one is the table of radicals. All right, and you will find various like these are the chains. All right, N-propyl, N isopropyl, all right, secondary butyl. These are the chains, and these are the cycles, like 3, 4, 5 membered ring. All right, and these are the carbon groups like vinyl group, ethynyl group, cyano group. Right, so these are the elements, and these are some miscellaneous radicals. All right, you will find lots here, and these are the amino acids. All right, so any amino acids you want, you can choose from here, and these are some of the protecting groups. All right, so it is useful. Below this table of radical, you will find a benzene ring. If you want to draw any benzene ring, just select it and place it here like this. If I want to place the second benzene ring, I can place it all around anywhere. All right, it will show me all the possible also all the possible directions where I can place this, like this. All right, and now moving on to the next structure, it is cyclohexane. Alright, so I can place it like this. This one is a 5-membered ring. Let's say I want to place it as this. Alright, so it has been placed. This one is the tert-butyl. This is isopropyl group. Alright, this is the COCH3 group, and I want to place it like this, so you can see. Alright, I just don't want this, so what I'm going to do is I'm going to select it and just delete it. All right, this one is the benzoyl group. Let's say I want to draw it as benzoyl group here, so I have drawn it here like this. This one is the nitro group. I want to place it here like this. This one is the acetoxy group. Let's say I want to place it like this. This one is the sulfo, and this one is the phosphono group. All right, at the end there is a user template group. So here you can add or remove any radical, any label or something like this. All right, so it is of no use to us. I'm going to select it like this. All right, so I selected it, and I'm going to clean the structure. Okay, and then I'm going to drag. All right, so the structure has been cleaned, and if I want to know the alright, so we had completed the left and right panel and all the icons here. Now moving on to the topmost icons, let's see what are in these icons. Alright, so these icons are basically you can see these are the save and save file option. This one is used to open any file, this one is used to print, and this one is used to save if you want to import this PDF. Sorry, this we can see how we can export it to PDF. All right, and this one is used to undo, and this one is used to zoom, and this is the important option, that is delete option. All right, and this is one is used to zoom the structure, zoom in and zoom out. All right, and this one is the page width. You can select it as page width, it has already been fixed. All right, and this one is the full page option. This one is alright, so this is the full page, this one is the full page option, and this one is page width, so the page will be will fit the width of the window, and this one is fit on. All right, so it has been zoomed, you can say it like this. Now this is the template window, and this is really very useful in order to do big structures of some aromatics or some bicyclic rings, carotenes, chains, crown ethers, like the big structures. All right, amino acids, let's say. All right, so you can see these are, and there are 4. Like this is the acids. All right, and below you will find L acids. After this, the R radicals, and these are L radicals. All right, next one is the anions, all the inorganic anions, and we have 2. So these are the inorganic anions, and if I want to say organic anions, so these are the organic anions. All right, acetate, succinate, fumarate, malate, and all these. Next one is the aromatics, and if you want any big chain or aromatic compound, so here are some of them provided. All right, so these are aromatic fused systems. Like if you want saturated fused systems, then you can get it from here, and calizarenes and cyclophanes. All right, so you can get it from here. Next one is cyclacenes and phenacenes. All right, so these are the cyclacenes and phenacenes. After this, it's helicenes. Right, so you can see this is the helicenes. After this comes the arrow, like any specific arrow you want in order to draw any structure. You know, like sometimes we draw any cyclic structure, or we show any structure, any chemical reactions, mechanism of any chemical reaction in a cyclic manner, then these are some of the arrows which are frequently used, and these are not provided in the Chem Draw Ultra. All right, so in the page 2 where we'll find it in colorful way. All right, the next one is the bicyclic rings, and these are of really importance. So these are C5 to C9 bicycles. The next one is C10 to C11 bicycles, and after this comes the C12 to C13 bicycles. All right, next comes the carbon groups. All right, so these are some groups. After this comes the carbohydrates. All right, so these are the Fisher projections of carbohydrates, and if you want Fisher plus stereo, so these are the Fisher and along with the stereo projections, and this one is only the stereo projections of the carbohydrates. After this comes the carotenes. All right, and there are also 5 page. All right, so different carotenes are provided here, you can see. Next one is the chain, like these are the normal chains. All right, you can get it, these are the saturated, and if you want the unsaturated chains, then you can get it from here. After this, crown ethers. All right, so these are the crown ethers. After this comes the DNA or RNA kit. These are basically the nucleotides and nucleosides. All right, so these are DNA and RNA components. If you want DNA components, you can get it from here, and if you want RNA components, then you can get it from here. Yeah, these are the figures. All right, so these are the DNA models we use basically in order to draw. These are the lipids, or bicyclo. These are usually the viral RNA protein capsid or something like this. All right, after this there are fullerences, C60 and C70 fullerences. Alright, and if you want miscellaneous fullerences, then some of these are also provided here. Alright, so these are some HPLC kit or pumping systems like used in the laboratory. After this, these are the lab equipments, alright, usually used in order to draw structures. After this, these are the Newman projections. Alright, these are eclipse, gauge, eclipse anti, and gauge. These are some of the orbitals. Alright, so here are the phosphorus compounds. After these are the steroids. And at last comes the sugars. Alright, so these are the Haworth formulae of sugars. If you want cheer presentations, you can select it from here. Stereo projections and Fisher projections. Alright, when you draw any chemical reactions related with the carbohydrate, then you particularly need this Fisher projections. Okay, so these are all. Alright, this is all about the user template. And moving next, what else is there? So beside user template, this is the search for structure. Alright, so this option is not given here. Alright, this one is convert structure to name. Alright, so if there is any small structure or something like that, then it will predict. In some big structures, it usually doesn't predict. So the next one is the smile notation here. Right, now what does SMILE stand for? The SMILE stand for Simplified Molecular Input Line Entry System. I'm going to write it here. The SMILE is Simplified Molecular It is Simplified Molecular Input Line Entry System. So this one is smile. Like smile is just basically a notation. Like say if you want, it is like it is the simplified molecular input. All right, simplified molecular input or a specific notation in the form of a line. All right, you can describe this big molecular structure just in the form of a simple line, in a simple line. All right, so this is the basically smile. All right, so this one is the smile notation. All right, I'm going to delete it here. I'm going to delete this. All right, so this one is the smile. Now beside this is the PubChem. Like if you want to search this on PubChem. Now what is PubChem? PubChem is basically a large chemical library with huge amount of structures. All right, it is a large chemical library. All right, so after this comes these are four. You can see these four are the selection panels. All right, tools. All right, so before explaining this, I want to just clean the structure. So I'm going to select all these. I'm just going to delete it. All right, so just delete it now. All right, so below this comes the yeah, so this one is used to draw simple bonds. All right, like say CH3 or say CH4, or say if you want to draw it as like this. All right, and like say if you want to clean this structure, just select it and clean. All right, so this one is also useful. This is used to clean the structure particularly. All right, so you can see the structure has been cleaned. All right, so these are basically used to draw the normal structures. If I move on to this then this is used to draw continuous bonds. All right, like say if you want to draw the structure of normal pentane, all right, having 5 carbons. So what I'm going to do is 1, 2, 3, 4 and 5. All right, so you can see this is the normal pentane. What I'm going to do is, again I'm going to select it and I'm going to clean the structure. All right, so you can see this one is the normal pentane. All right, so and this the next is draw chains. Like this is used to draw chains. Any that depends on you how long you want to draw the chain. See 29, 34, 32, 14, 13, 10, 8. All right, as long as you want, you can draw it using continuous trains. All right, now just continuous trains. All right, now just clean this page. All right, so again select these structures and just delete it. Now this page is clean and I like cleanliness a lot. All right, so the next one is this. Let's say if want to delete this bond and I want to delete this bond also. All right, and I want to draw the stereo bonds, up stereo bonds here. All right, now let's say I want to draw the stereo bonds. So I'm going to select it and yeah, like this. All right, and if I want to draw down stereo bonds, I will select it and just place it like this. Again, I will choose, I will select this structure, this whole structure, and I will clean this structure. All right, so this is the perfect structure. All right, after this comes the R and S, you know, like chiral carbon, and we know you have to put their R and S notation, so you can do it using this. And this one is used to generate stereo descriptors. All right, and this one is used to enhance the stereo. Yeah, so all right, after this comes the coordinate bond. If you want to see any coordinate bond, if you want to show any coordination bond, then you can use this bond. All right, and this one is the undefined stereo bonds. Right, so undefined stereo bonds, you can use this. All right, the next one is after this, these are the dotted delocalization curve, like this. Branching are not allowed in this location. All right, let's say you have drawn any 3-member drink. Let's say I've drawn this. All right, and I'm going to delete option. I'm going to delete this bond, delete this, yeah, this. All right, and now I want to choose it. Yeah, you can see. All right, so this is the cyclopropyl. All right, so you can draw it like this. After this, this is just to add or remove any fragment in any reaction. You can use this. All right, this is used to hide or atom numbers or show atom numbers, like these atom numbers have been shown here. All right, this one is used to show the reaction. All right, so this is used to show atom numbers, or in order to do numbering you can use this. This one is used to draw any chemical reaction. And the next one is the reaction arrow. All right, this one is the labeling. This one is used to label. All right, this one is used to label any arrow. All right, and this one is the reaction calculator, and this one is used to put the vertical bond. Right. This one is used to set horizontal bonds, and this one is used to set vertical bonds. All right, and this one is used to flip bond. All right, this one is used to flip top to bottom, and this is flip right to left. All right, sometimes in descripting sometimes during stereochemistry and organic chemistry we used to flip some bonds. All right, while doing R and S nomenclature and all that, so these are useful there. This one is used to clean the structure and it is important. And this one is used to check the tautomeric forms. Alright, as I told you, this one is a 3D optimization. Alright, and this one is to calculate selected properties. Alright, like chemical formula C8H17. It is particularly of this structure. Alright, its formula, weight, its composition. Alright, and after that it's dielectric this is not available, monoisotopic mass and all that. Alright, some basic properties can be predicted. And this one is the biosequence tool. The biosequence tool contains some particular acids. Alright, so A for alanine, C for cysteine, and V for valine. These are some acids, and these are some non-standard acids. Alright, like citrulline, hydroxypyrroline, and isoleucine and all that. These are some groups also, acetyl group, benzyl group. Right, so these tools are basically useful in order to draw your structure faster. Alright, so I had told you each and every basic things about ChemSketch and how you can use this ChemSketch in order to draw chemical structures. Alright, now some options also, like edit option. Alright, these are some basic options. Alright, everyone can understand. So color option here, if you want to change the background of this page, you can also do it. Alright, like I want it to be lemon yellow. Okay, so this one is like this, so you can choose this. Alright, after this, the header and footer, if you want to edit the header and footer, so this option has been given here. The next is the tool option. Is under it comes the structure properties, like as I told you here also, the structure properties, the basic structure properties. This is clean structure, check tautomeric form, all these have been explained here. Alright, this one is used to add or remove hydrogens. Alright, add or remove hydrogens are also alright, and like bring bond to front, set bond to back. You can also do it like this. Alright, the next one is a template window, template organization, table of radical, and all these have been explained. The next one is show grid. Alright, so this the grid appears if you select it like this, and just remove it. If you want so RSS, so it will show your setup RSS. We don't want, these are of no use to us. Alright, we just want a basic. Alright, add on, like if you want to, if you have drawn any structure and if you want to search it on a Chem Spider, PubChem, e-molecules. Alright, so you can use you can search, you can select and click on it, and it will search the PubChem ID or the Chem Spider ID of that molecule. The next one is enumerate marker structure. Alright, so enumerate marker structure. So as these structures doesn't possess any markers fragments, so it has not been depicted here. Alright, so these are some drawing styles. You can select any one of this, it just doesn't matter. And the next one is add-on, alright, so I want to make this tutorial in order to understand the basic hand-on tools and the basic function of the icons provided in the ChemSketch. As whenever you draw any structure, whenever you want to do your hand free on any particular software, it's really very necessary to understand the function of a particular tool. Alright, and once you understand it, it becomes really easy to draw any structure. Alright, so from draw, I remember that here is another option called draw. Alright, and from draw you can also draw any structure, like this one is a rectangular option. Alright, so you can draw it. Artistic text. Alright, so these are also some options you can choose, like if you want to select the arrow. Alright, so there's not much option as in the structure menu, but you can use it in order to have some specific structure. You can use that one also. Alright, so I hope this tutorial is beneficial to you, and I will make one more tutorial on some of the specific points or key features of ChemSketch. depicting all that, and drawing some particular chemical structures on ChemSketch. We will draw some big structures on ChemSketch. All right. So thanks for watching the video, and friends, if you had not subscribed my video, please subscribe my channel for more interesting videos. I will make tutorial on each and every topic related with computational chemistry, and thanks for watching.